So when we cover the parent functions, remember we spent a whole lot of time graphing them, and that at the very end, I would give you the graph and you would give me back what? The equation. Okay, that's the same thing we're doing here. We've spent a whole lot of time graphing polynomials. Now I want to give you information and you have to give me back the equation. Okay, so let's talk a little bit about some of the stuff we've known. When we have polynomials, so a polynomial that has an n degrees, okay, so 5, 6, 7, whatever the degree is, that polynomial will have at most n roots or zeros, okay? So a third degree polynomial can have at most 3 roots, okay? The other thing about these polynomials is they can have at most n minus 1 turns in the graph. What does a turn mean? Yeah, like you were going west, but then you turned and now you're going east, okay? So if you look at this graph, it was going down. It reached a point that it no longer went down and it started going up. So there's a turn. This has 2 turns in it. Or excuse me. Here's a turn, and here's a turn. So this one has 3 turns, okay? So that means if it has 3 turns, it has to be what degree or more? Okay, if it's nth degree, it could have at most n zeros and at most n minus 1 turns. This has 3 turns. The degree has to be what? Okay, if the degree is 3, it's going to have at most 2 turns. If it's nth degree, it can have at most n roots, and it can have at most n minus 1 turns. A third degree can only have 2 turns. A fourth degree can have up to 3 turns. A fifth degree can have up to 4 turns. Right, so if this has 3 turns, it has to be at least a fourth degree polynomial, okay? So let's look at this one. What I have here is a fourth degree polynomial, okay? Looking at this polynomial, the leading coefficient is what kind of number? Leading coefficient of this guy. It is positive, okay? So I've got a fourth degree polynomial, positive coefficient, okay? It has at most 4 zeros. So this thing's going to have at most 4 zeros and 3 turns. That's all that a fourth degree polynomial can have, at most 4 zeros or 3 turns. Now what does this look like? How many zeros does this first one have? Zeros are where it crosses or touches what axis? X-axis. Do you see it doing that? Yeah. This one has no zeros. Okay. Now the same graph. What happened when I got from here to here? What did I do transformation-wise? It went down 1, but how many zeros does it have? This one has 1 zero. Okay. It looks like I moved it down another notch, and how many zeros does the next one have? 2. Okay. If you keep on going, how many zeros does the next one have? 3. And then finally, 4. So here's how a fourth degree polynomial can have at most 4 zeros, okay? If you move this one up, you get no zeros, you keep moving it down. If I were to keep moving it down, I'm never going to get more than 4 zeros. You know, it looks like I'll go back to getting 2 zeros if I keep moving it down, okay? So when you look at a polynomial, you're not guaranteed, you can't say it's fourth degree and has 4 zeros, but you know it's fourth degree, it has at most 4 zeros, okay? And at most 3 turns in the graph. So let's look at a third degree polynomial, okay? How many zeros does this one have? The first one has 1 zero. The second one has how many? 2. The next one has? Is there a way that I could get any more zeros out of that one? No, no matter how I move it, that's the most times it can cross the axis. How many turns does this graph have? 2. You know, it's going up, it went down. That's 1 turn. It went from down to up. It has 2 turns, okay? Now, if you go back to that fourth degree polynomial, remember the first one had how many zeros? None. There were no zeros, okay? Is it possible that a third degree could have no zeros? Why not? Yeah. Why is it not possible to have 0 roots, or what is it? It's going up and down. It has to cross. There is no way around it. So I can make this polynomial never cross. I can make this one never cross. But the ones that go like this, they have to cross at least one time. So if it's odd degree, it has to have at least one root. So what we're going to do in this section is use what we know about roots and factors, come up with equations, and graph these guys. So write an equation for a cubic function. What degree is that function? Come on, guys. A cubic function, what degree? Third degree. So I'm writing the equation for a third degree function with a negative leading coefficient. It has zeros at -2, 4, and -5. Draw a simple sketch. Include the x-intercepts, the zeros, the y-intercept. So what's the degree of this thing that I'm looking for? Third degree, okay? The leading coefficient I know is what kind of number? Negative. It is negative, okay? So immediately, what do I know about the shape of this? Third degree with a negative coefficient. It's going to go like this. Okay, so I know immediately, before I do anything else, this is what this graph does. Okay, so that means the answer to that first limit is what? Infinity, and the second one is negative infinity. Okay, so that part I know. Now, I know that it has zeros at -2. So if it has a 0 at -2, what has to be a factor? X plus 2 has to be a factor. Okay. It has another 0 at 4. What has to be a factor? X minus 4. It has a 0 at -5. What has to be a factor? X plus 5. Okay. Now, will there be any more roots? What degree is this? Third degree. What's the most it can have? 3. I can't add any more and get a third degree. Now, third degree, what did it say about the leading coefficient? It's negative. The one that I just drew, what's the leading coefficient down here? How would I make it negative? I could stick a negative in front. So that is a third degree polynomial with a negative coefficient. It has zeros at -2, 4, and -5. So the x-intercepts are what? -2, 0, 4, 0, -5, 0. Okay. How do I find the y-intercept? Yeah, if I plugged in x equals 0, this becomes -2 times -4 times 5. So that becomes what, 40? So the y-intercept is 0, 40. So I should be able to graph this guy now. So somewhere up here, that is 0, 40. Is there any multiplicity here? No. So I would do what at each of those x-intercepts? Cross the axis. So at -2, that's right there. At -5, that's right there. At +4, that's right there. So I cross at each of those points. Where do I start, up or down? Yeah, so I need to be able to go cross, cross, hit that, cross, and end in the quadrant going down. So that is all possible. So I start here, I go like this, and that is it, okay? So here, most of the problems so far, I've been letting you start here and then give me all this information in the graph. Now I gave you information, you came up with the equation, and you were still able to do the graph for this guy. So not a whole lot different, just a little bit of a different skill set to come back with the equation. So you got to be very comfortable moving between what does it mean to be a root and what does it mean to be a factor. Now there are just different ways I can ask this question. This is probably the most cumbersome way to ask it, but you guys can power through it. H of x is a 6-degree polynomial such that the limit as x goes to the left is -infinity, and as I go to the right is -infinity. So what do we know about a 6-degree polynomial that does this. It's got a negative leading coefficient. It's a 6-degree polynomial, okay? So they told me that the limits were here were negative infinity. Negative infinity. Yeah, I'll give you points for that. If it's in the box there, I usually give points for that. Now, what does this mean? H of 5 is equal to 0. Yeah, what's x? 5. What's y? 0. So it tells me that this thing goes through the point. You plug in a 5, you're going to get a 0. You plug in a 1, you're going to get a 0. If you plug in a 0, you get a 0. You plug in a negative 2, you get a 0. And you plug in a negative 5, you get a 0. And you plug in a negative 8, you get a 0. These are all the what? X-intercepts. If y is 0, then these are x-intercepts. Okay? So, is there any multiplicity here? Is there? No. So it means, what do I do at each of these points? Cross the axis. So 0, 0. Okay, it looks like 1, 0 is right there. I've got to go out to 5, 2, 3, 4, 5. And let's see, negative 2, negative 5, and negative 8. So all of those are there. Okay. Now, how do I find the y-intercept? So let's come up with what our equation is going to be. So this function is going to have a negative leading coefficient, right? What is the factor going to be corresponding to this root? Yeah, x minus 5. What? X minus 1. X minus 0. Okay, that's just x, right? Okay. It's okay. X minus 0 is fine. X plus 2. X plus 5. And x plus 8. What is the y-intercept? It's what? Yeah, you plug in a 0 and you get, plug in a 0, you get 0. So the y-intercept is 0, 0. Okay, I can. This would be negative 5 times negative 1 times, what's this number? Yeah, you get.
Oh, I'm tripping. I started adding after I got 0.
No. So this one worked out well. So where does this guy start? I start below. So I just need to cross at all these points. I need to start here, cross everywhere, and end down. So I can go up, down, up, down, up, down. Yes? No, it doesn't bounce because it's not occurring multiple times. If I had this situation, if I had x squared, like this, Gilday, if I had x squared, it would not cross at that point. Okay? So this graph is going to start, so it's going to do something like this. So it threads its way through each of those points. Okay, you guys work on the next one here. So it's what? What is the degree of this one? 5th degree. Okay, the limit of q of x as x goes to negative infinity is negative infinity. So that means it's going down as I go to the left, right? If it's 5th degree, what is it doing to the right? Come on, guys. It has to go up because it's 5th degree, okay? So this is what? Negative infinity to infinity. Okay. So the leading coefficient has to be what? Positive. It has to be a positive leading coefficient. Okay, I know that already. It passes through these points, 2, 3, and negative 1. So those are my what? X-intercepts. it only crosses the axis at 2 and 3. So that's telling me, what does it do at negative 1? It does not cross. That means what? Yeah. So this tells me there's a multiplicity of 2 at x equal negative 1. And wait, let's see. 2, 3, and negative 1. It only crosses at 2 and 3, but this is a 5th degree. I'm trying to think if there's other. Okay, I need to make a change to this one. It's a 4th degree. Okay. If I go to the left and it goes to negative infinity, if it's 4th degree, what does it do to the right? Okay, so the answer to both of these are negative infinity. Okay. Now, here are all my x-intercepts, but I'm told that it only crosses at 2 and 3. That means it does not cross here. So that means I've got a multiplicity. So if I had x plus 1 to the power of 2, and this would be 3 and 4, this would get me my 4th degree polynomial. How can I tell what? It's 4th degree. If I'm telling you that it goes to negative infinity on the left side, if it's 4th degree, it has to go to negative infinity on the right side. Okay, if it were 5th degree, it would do the opposite. So now, what's the equation of this guy? So it's going to be q of x equal what? X minus 2, x minus 3, x plus 1 what? Squared. And since it points down, the leading coefficient is negative. Okay, so that is a possible equation that meets all these conditions. What would the y-intercept be? Yeah, it's going to be 0, negative 6. So it's going to cross at 2 and 3. So it crosses here and here. There's 0, negative 6. It does not cross at negative 1. Okay. So is it possible to start down here? I could bounce, cross, cross, and then end up in the bottom? Yes. So it has to do something like this. Okay. Let me make myself a note to check. What page is that? What? 227. So it's a 4th degree. I'll have to talk to the book editor about that one and see how that one fell through the cracks. Okay. So here's where it gets just a little bit of an extra step that you got to pay attention. Every question so far has been find a polynomial, find a possible polynomial that meets these conditions. Okay. So what could happen here is I've got negative x minus 2, x minus 3, x plus 1. Another polynomial that meets these conditions is negative 4, x minus 2, x minus 3, x plus 1 squared. That meets all these conditions. You know, negative 14, you know, negative, 714. That's all these polynomials have the same properties. They have those same zeros and all of that. Okay, so we've been finding possible polynomials. So anytime you have a question that says find the exact polynomial, that means I want the leading coefficient to be exact. Okay, and I have to give you a little bit more information to make that happen. So if I give you all the zeros and I give you one other point, I can ask you for the exact equation. Okay, so find the exact polynomial that passes through all of these points. These points right here are called what? X-intercepts. So I know what to do with those. So I know that I'm looking for a polynomial that there's some leading coefficient. At this point, I don't know what it is. I've got a leading coefficient, but what are my factors? X plus 4. Yeah, x minus 4. Okay. So I know that it has to pass through all of those points. Those are all factors. Okay. Now 0, 10 is not an x-intercept. What is it? Yeah, this one is a y-intercept. So 0, 10 is a y-intercept. So I can't write x minus 10 as a factor. You only do that for your x-intercepts, okay? So now what I got to figure out, this says that when you plug in a 0 for x, what had you better get for your y value? Yeah, when you plug in a 0 for x, you need to get 10 back for your y value. So let's do that. Let's plug a 0 in for x, and what should my answer be? Yeah, so since f of 0 equal 10, that means that when you substitute x equals 0, you should get y equal 10. Yeah, so what I should get here is I'm looking for what is the solution to 10 equal a, 0 plus 4, 0 minus 2, 0 minus 4. When you plug in a 0 for all your x's, your answer has to be 10. Okay, so now I just do a little bit of arithmetic. So 10 is equal to a times 4 times negative 2 times negative 4. What number is that? That is what? That is what, 32? Is that right? So I get 10 is equal to 32a. How do I solve that for a? Divide by 32. So 10 over 32 equal a, or you could write it as 5/16 equal a. Either one of those is okay. So what is my exact equation? My exact equation is f of x equal 5 over 16 x plus 4, x minus 2, x minus 4. Now, do you see how this is a little bit different? I have people all the time on the test who will they're okay with everything, but they struggle or even forget to solve for this coefficient. If I ask you for an exact equation, so what was the wording of this one? It said, find the exact polynomial. If I say find the exact polynomial, I'm needing you to solve for what that leading coefficient is. So what I would need to give you, the x-intercepts, and I have to give you one other point. That's how you use it to get the exact equation. So let's do another example here. Find the exact equation of a polynomial that has a multiplicity of 3 at x equal 2, passes through negative 1, 0, negative 2, 0, and 0, 5. Okay. If it has a multiplicity of 3 at x equal 2, so I know this is going to be equal to some leading coefficient. It has a multiplicity of 3 at x equal 2. What's the factor? X minus 2 cubed. It has a multiplicity of 3 at x equal 2. It passes through negative 1, 0. That's an x-intercept. What's the factor? X plus 1. It passes through negative 2, 0. What's the factor? X plus 2. Okay. Those are all the x-intercepts. That other point is 0, 5. So 0, 5 is what? That's my y-intercept, right? That says if you substitute in a 0 for x, what do you get for y? 5. So this tells me that 5 has to equal a 0 minus 2 cubed, 0 plus 1, 0 plus 2. So 5 is equal to a times negative 8 times 1 times 2. That's what, negative 16? 5 equal negative 16a. So what is a? A is negative 5 over 16, right? So what's my final answer? F of x equal negative 5 over 16, and then what? Yeah, all this other stuff. X minus 2 cubed, x plus 1, x plus 2. What does the graph do at each of those x-intercepts? It crosses at every one of them, okay? What degree is this guy? Degree. 5th degree. So what's it going to look like? It's going to look like this or this? Yeah, it's going to look like this because it has a negative coefficient in front of it, okay? Yeah, whatever you need. Okay. That's fine. I don't touch it. I mean, okay. Let's look at another one here. K of x is a 3rd degree polynomial. So what's the degree? 3. Okay, you don't miss that one, okay? The limit as I go to negative infinity is infinity. So if it's a 3rd degree, if it's going up over here, what's it doing over there? It has to be going down over here. So if it goes up to the left, it has to go down to the right, okay? What's the leading coefficient got to be for this one? Yeah, it's got to be a negative coefficient. So all of that I know just from reading that first sentence. It has a double root at x equal 2. What do you think a double root means? Yeah, it's a root of multiplicity 2. So finding, and here it says find a possible equation. That means I don't have to go through this thing of solving. So I know that it's going to be negative coefficient. What's the factor that corresponds to that situation? X minus 2 squared. It's a double root, okay. A single root at 4, what does that mean? X minus 4. What degree is this guy? 3rd degree. I think I'm done. That's it. Find a possible equation. That's it. Okay, how do I find the x-intercepts? They're what? 2, 0, and 4, 0. I didn't ask for it here, but there is a multiplicity of what? Of 2 at x equal 2. What's the y-intercept? Is it 0, 16? So to graph this guy, so up here is 0, 16. And then what happens at the 2 and the 4? So I cross at 4, and I do not cross at 2. Okay. So how does this work? So I have to start where? At the top. So this one, in order to make this, I can't come. Why is it wrong to do this? Yeah, I don't have any other crosses, so I can't do that. So that means it's going to have to start out something like this. It's going to have to come down like this, right? So it does something like that, and then it has to bounce and cross. That's the only thing that it can do. Okay? And I think, are we about done, or is there another one? One more. Find the exact polynomial that passes through all of these points. So when it says exact polynomial, I have to give you all the x-intercepts and one other point, okay? So if it passes through all of these points, f of x, if I'm looking for the exact polynomial, that means I've got to find out what that leading coefficient is. So what are the factors? X plus 4, x plus 2, x minus 2, x minus 5. Why is x plus 10 not a factor? Yeah, that's not an x-intercept, that's a y-intercept, okay? So I know that when x equals 0, I'm going to have to get y equal negative 10, or f of 0 equal negative 10. So let's just use that for a fact, and I get negative 10 is equal to a. Now what happens when I put zeros in? I get 4 times 2 times negative 2 times negative 5. And that is what, 10 times 8, that is 80. 10 times 8, So negative 10 equal 80a. So what is a? Yeah, negative 10 over 80, which is negative 1/8. So what is my final answer? My final answer is, yeah, f of x is negative 1/8. And then copy down all that stuff from up there. X plus 4, x plus 2, x minus 2, x minus 5. Okay? So this should feel like a nice ending to what we've been doing, not too terribly complex. So what we've done, if I give you the roots and information about end behavior, you can figure out what the leading coefficient, positive or negative. You can write a possible polynomial. If I give you the roots, guys, if I give you the roots and one other point, a y-intercept or some other point, I can ask you for the exact polynomial. To find the exact polynomial, you're going to have to set it up like this and then solve for that leading coefficient to make that work. Okay, that is it.